Okay, so what we are starting for the rest of this week, next week, for a pretty long period of time is going to be laws of exponents. So before we start with laws of exponents, do you remember what exponents are? What are they?
There's a little number.
Okay, there's a little number, and what operation is used when we're talking about exponents? It's repeated multiplication. Okay, so before we go through and do all this, there are laws of exponents, meaning what happens if you're multiplying terms, how do the exponents get affected? There are, I think it's 6 different laws that we are going to learn. They're all on your formula chart. So you'll always have that to reference, but it looks kind of weird on your formula chart, so you have to have an idea of what it is before you look at it. We're going to be learning 2-ish a day for the remainder of the week, but today we're going to focus more on vocab and like what the different parts are of our terms and what those exponents are meaning and like what happens if we expand it or if we put it in that exponential form. So this part, right here, that's a term. This 5x squared, that whole thing is a term. That term has multiple parts in it. That term has a coefficient, it has a base, and it has an exponent. Anyone know what the coefficient is for that term?
5.
5. The coefficient is 5. Do you know what makes something a coefficient?
Big.
It's in front, it's in a term, it's in front of a variable. Then we have a base. Anyone know what the base is in this situation? X, it says number, it can also be base variable. But it's just our base. Does anyone know what makes something a base? It doesn't have to be a variable. A base could be a number. It's the part that has the exponent attached to it. Whatever part has the exponent, that makes it a base. And then what's the exponent in our terms? 2, what makes something an exponent?
That's how much it's.
It's how many times you have to multiply whatever the base is. It's the tiny number at the top. So it's that tiny number, and it's telling you how many times to multiply. If we have exponents, that exponent is representing repeated multiplication, so we can expand it. Expand it means take away the exponent, write it out as that repeated multiplication. So how could we take this term and expand it? 5 times x is written has an exponent of 2, so x times x. That is the expanded version, taking away any of the exponents. Now, before we move on to that one with all the y's right underneath it, I want you to add this into your paper. Right underneath, right before we get to the 2 times 8 times y, put in 5x and then squared. Make sure you write it exactly as I wrote it. How is it different from the term we had before? Yes? Say again?
You're also squaring the 5.
Okay, how do you know you're also squaring the 5? It has parentheses. If there are parentheses, it is changing what the exponent goes to. This is now saying that we have 5x times 5x. We write that whole thing that was inside the parentheses twice. Or we can write it if you want to separate it so the 5s are together, so 5 times 5 and then x times x. You can do that as well, because you can switch around multiplication. Either way to write it. But the parentheses make a difference. That is going to be huge when we get into all of the different laws that we're going to do throughout the week. Parentheses make a big difference. Okay. So let's go to this next one. This is given expanded form, and we need to write it in exponential form, meaning it's the long version, we want to shorten it. How could we shorten it? Can we write the 2 with an exponent? It's only there once, so 2 times 8, and then y, and it has an exponent of 9. Now, is there something else we could also do? Yeah, we could change, instead of 2 times 8, we can just make this 16 y to the 9. Because exponential form is really just asking you, can you simplify it? How much can you simplify that expression? 16 y to the power of 9 is our most simplified version. Okay, so you have 3 tables left on this sheet of paper that you have. There's one on the front, and there are 2 tables on the back. I want you doing all 3 of those tables with whoever you're sitting next to, and then we'll check it in a little bit. Got it? Okay. Okay, so on that front one, I left a few of these blank because I was going around and checking. I think for the most part, everyone had the ones I filled in, but the ones I have blank. On number 3, what's the exponent for that situation? There is something.
1.
It's in 1. It is not 0. 0 is one of our exponent laws that we're going to be doing. Exponent of 0 is something different. It's just like if you ever have a variable like just the letter x. What's always been told to you is in front of x. It's nothing there. A 1. It's the same with the exponent. If you don't see an exponent, it's really just a 1 there. For number 4, what's the coefficient?
1.
What makes something a coefficient? It's in front of a variable. Is there a number in front of a variable? So that means there's none. And your base is 3. What about number 5? What's the coefficient?
No coefficient either.
We just talked about it.
1.
1. If there's a variable, if there's not something in front, it's really just a 1 right out there. And then for number 6, is there a coefficient? Is there a number in front of a variable? What number is in front of a variable? So 7 can be part of the base and the coefficient. How many are still working on the back ones? Okay, a few, so we'll wait a little bit. Are there any questions about the ones that are filled in so far? Look at this last one, number 20. How come there's no variable, or there's no exponent?
Because it's just 1.
Yeah, nothing got repeated. They all just have an exponent of 1, which you don't have to write an exponent if it's just 1. There are 2 I left blank. There is something you needed to use for number 16 and number 19, the ones I left blank. What needed to be used? Parentheses. So 16 should have been 5z to the power of 3. In parentheses is that 5z. And then for 19, 4x squared to the power of 4. Because it was written 4 times. Yes, you can do more with that. That is one of our laws that we're going to be learning for this week. Those are called powers to powers. You could do more with that, but we're going to see it later. For now, we're just going to leave it.